Thank you very much. All right, my name is Daniel Bohannon, and today we're going to be looking at Invoke-CradleCrafter, which is a PowerShell obfuscation framework that I released just a few months ago. A little bit about myself. I work with Mandiant out of the Washington, D.C. area. This is my first time in Sweden, and you guys have amazing coffee shops here. Can I just say that? I think I've hit at least 3 or 4 coffee shops in the past 24 hours, so really beautiful city. I'm really happy to be here. So for the past 2 years, I've been doing incident response consulting with Mandiant, and then the past several months, I've actually transitioned into more of a research position. So I do a lot of detection, applied research with a couple guys there, really having a good time. So a quick outline. This is only 30 minutes. I'll be moving very quickly. The slides are available online, and we'll see what we can get through. So first, I'll look at motivation, why I started this research, and then we'll look at kind of the current state of PowerShell detection, particularly to obfuscated PowerShell. And then we'll look at the new techniques introduced in Invoke-CradleCrafter, particularly when I use the word cradle, it's looking at a very simple one-liner command to download a remote resource and execute it in memory, which is oftentimes what we see attackers do when they use PowerShell. Then we're going to look at detecting these cradles. So I'm a blue teamer. So whenever I look and research these areas of obfuscation and offensive tooling, I'm looking at it from the perspective of what can I learn as a defender, what artifacts are left behind, so that in both a real-time and a forensic perspective, how can we detect this activity happened? And as you'll see in the tool, I put all the information into the tool itself, so that as both a red teamer and a blue teamer, when you go through the tool and look at the techniques, then all the information is there as to what it's doing, what artifacts are left behind. So hopefully that's useful. And then at the end, we'll go through a quick demo of the tool. So my disclaimer, whenever I talk about PowerShell, I typically get a few questions afterwards. And so I just want to answer those up front. Blocking PowerShell, this is not really a realistic option. And the reason is PowerShell is not just PowerShell.exe. That's the most common host application. But it's actually the system management automation.dll. And there's a ton of ways you can load that and issue PowerShell commands without PowerShell.exe ever running. And so why is blocking PowerShell.exe really not a great solution, in my opinion? Well, that leads to the second point. Noted blue teamer Jared Haight once said in a conference, PowerShell is not special. And what he meant by that was attackers often will use PowerShell just to download a stupid binary to run. So people are worried about this as a PowerShell problem. It's like, no, this is a problem of your user opened up a macro and allowed code to execute. PowerShell just happened to be what was used to download something else. And third is PowerShell 5.0 is your new best friend. The PowerShell team at Microsoft has introduced incredible security developments into PowerShell 5. And there's 2 links here looking at, from a logging perspective, all the advantages you get with PowerShell 5, and then a lot more preventative measures such as GIA, just enough administration, stuff like that. So my motivation. As an IR person at Mandiant, we see PowerShell being used at literally almost every investigation that we get our hands on. The reason is it's a Windows signed native binary, available by default Windows 7 and later, and you can execute remote code in memory without anything hitting disk, which attackers like a lot. Now, it's basically impossible to detect unless you have at a bare minimum command line argument logging, and that will capture some stuff, but really PowerShell logging is what you want to get to, specifically script block logging in addition to module and transcription logging. So some of my colleagues asked me, why do I continue researching more ways to obfuscate PowerShell? Because it makes our jobs incredibly more difficult the more of this stuff that's out there. Well, and the answer is that attackers are getting more and more creative as well. So I feel like it's important to try to stay ahead of them and enumerate all these possibilities and then share that openly with the community so that we can all get better together, especially from a defensive perspective. So yeah, Invoke-CradleCrafter is kind of a living library of all the different ways that you can use PowerShell to download content, either in memory or to disk. So the current state of PowerShell obfuscation, there's a lot of it out there. So exactly 1 year ago, I released this tool called Invoke-Obfuscation, which basically automates a lot of different layers, 4 in particular, of PowerShell obfuscation. You have the token layer, string layer, encoding, and launcher. And so, again, this is only a 30-minute talk, so I'm not going to dive into this too deeply, but basically you can have a remote download cradle like this at the top, and Invoke-Obfuscation will do things like concatenate strings with single quotes, double quotes, white space. It can take something like download string, and this is just one method of the net.webclient.net class, but there's a lot of other ones that a lot of defenders aren't looking for. Download string is the most common, but you have a lot more. And this is where Invoke-CradleCrafter will actually take advantage of this, because these all return different formats of results, but Invoke-CradleCrafter can actually take that and swap them out, which we'll see later. But Invoke-Obfuscation will say, I don't care what the method is, I can put single quotes around it, I can put double quotes around it, and it all still runs fine. I can put a tick mark in it. I can put a lot of tick marks in it. And this persists both in command line logging as well as all the way into PowerShell script block logging as well. So as defenders, if we're looking for download string and logs, we're going to get burned this way. Now, this will show up correctly in PowerShell module logs, but there's a module log for every single parameter binding and stuff like that for a single script. So one script, you could have hundreds or even thousands of module logs. So all the information is there. It's just spread out in a lot of different pieces. You can put tick marks in front of arguments. For new object is a commandlet. So Invoke-Obfuscation will treat any commandlet, and it'll do things like options 1, 2, and 3. Put tick marks, it'll concatenate it, and then invoke it, or option number 3 is actually reordering with that -f format operator. Now, Invoke-CradleCrafter introduces 2 more techniques. So Invoke-Obfuscation is completely different from that of Invoke-CradleCrafter. CradleCrafter will go and say, okay, well, let me just say get command for new object and then invoke the string that comes back. Or let me use number 5 as the PowerShell 1.0 syntax to do that. But instead of specifying new object, we can do that and use wildcards, and that will return new object and allow us to invoke it. And instead of get command in that execution context, we could actually obfuscate that as well. And all these components that can be swapped around, Invoke-CradleCrafter will randomly obfuscate each of those for you. And actually, I designed the tool to give you a lot more control over which parts you swap, and so we'll see that in the demo. So, invoke expression. As crazy as the obfuscation got in Invoke-Obfuscation, this is the only overlap between the 2 projects, and that is obfuscating the string IEX, which is the alias for invoke expression. So in this example, shell ID is an automatic variable in PowerShell. It resolves to the string Microsoft.PowerShell. So if we just take the index 1 and 13, that's the letters I and the E, and then we add an X and invoke it, that's now IEX. So Invoke-CradleCrafter has over 10 different invocation options, these concatenated ones just being one of those options. So that was token layer obfuscation. String layer obfuscation, you can take the whole command and concatenate it, reorder it, completely reverse the command, and then reverse it again in memory. The third option is encoding. There's 8 encoding options. The last 2 just released at Black Hat a month ago, using 100% special characters and then also white space and tab encoding. And we'll look at this just very, very briefly on Friday as well. And then the fourth one is Obfuscated Launchers. Basically, how can you, even still using PowerShell.exe, how can you launch your code in such a way that it doesn't even show up on the command line for PowerShell.exe, using things like standard input, clipboard, stuff like that. So the current state of PowerShell obfuscation detection is not great. AV is still catching up. Windows Defender is doing some really cool stuff on that front, but in general, I've still not seen AV really catch Invoke-Obfuscation at a text level. Now, obfuscation is affecting static analysis. The heuristic-based detections are still in effect. So for example, if you're running Invoke Mimikatz, PowerShell is still going to be running, accessing LSASS. Obfuscation doesn't change that at all. But with that in mind, from a static perspective, still not seeing good detections for Invoke-Obfuscation. Some threat actors really like using it. APT32, which is also known as Ocean Lotus, a Vietnamese APT group, they use it a lot. So my colleagues really like that, and they send me those samples to decode for them, so payback. AMSI, or AMSI, Anti-Malware Scan Interface. This is available in PowerShell 5, and it's much more than just PowerShell, but a really cool feature that Microsoft enables registered AV vendors to tap into. Some really cool opportunities there, basically giving you visibility into exactly what you see in script block logs. So you still have to take into account that first option, that token layer obfuscation, because that's not resolved in script block logs. And then frequency analysis and vector similarity. So Lee Holmes is one of the original developers on the PowerShell team, and he actually wrote a blog post last year after I released Invoke-Obfuscation, highlighting how you could detect that kind of obfuscation with frequency analysis. And this actually led to some good conversations between me and him, and eventually turned into a proposal for a project that we actually did and put together and released just a month ago at Black Hat and DEF CON called Revoke-Obfuscation, which I'll be talking about on Friday. So, the new stuff. MOAR cryptic cradles. First of all, this is the spelling of MOAR. I guess it's MOAR plus roar. I didn't know that when I first came across it, so also a good excuse to put a cat picture in there. So the 3 things we'll look at. First is insecurity by obscurity, I say. So there are obscure download cradles syntax that without obfuscation that a lot of defenders aren't looking for, like IWR, which is an alias for invoke web request. Now, granted, it's only PowerShell 3 and later, but attackers are already using this. Next, we'll look at obscure token obfuscation. So again, Invoke-CradleCrafter obfuscates entirely differently than invoke obfuscation. And we'll take a command like this and turn it into something like that, all without a single tick mark, without a single concatenation. And then obscure invocation syntaxes, we'll take a look at that as well. So I've broken out the cradles into disk-based and memory-based. And disk-based is often overlooked because usually it's stupid commodity malware that's downloading stuff to app data, and it's just an executable. But there's some interesting places you could download something to disk and get some benefit out of, like if you're downloading PowerCode and download it to the profile. Just a thought. So download file, bits admin, and then start bits transfer. Those are the 3 options currently in there. Bits, you might want to keep in mind there are certain settings on the server you're downloading from. It has to return the size of the file just because of how bits works. So sometimes you'll get an error like this depending on where you're hosting your payload, so definitely want to check that out. Fun fact about bits, and you'll see the CLM shield, that stands for Constrained Language Mode, which is an option you can have in later versions of PowerShell to basically lock down the available commands. And these both work in Constrained Language Mode. So it's, again, even though you have CLM in place, let's say, there's still ways to download content in PowerShell. And now these are the memory-based cradles. So download string, again, this is the most common one that we see attackers using. It returns the remote payload as an expression, typically to be invoked in memory. Download data and open read. These return as a byte array and then a byte stream, and so those will work just fine in memory. You just have to convert them appropriately. Invoke web request and invoke REST method. These are both PowerShell 3.0 and later. And you'll see in the tool, anything that has stipulations like PowerShell 3 or later, I have in like bright red letters so that you know exactly where it won't work if you want to use that option. But these are both also functioning 100% in constrained language mode as well. You can also just straight up call .NET classes in PowerShell. So the net HTTP web request, that's an option I have in there. Send keys. So if you're an attacker and you open up Notepad, and you go to open a file, and instead of putting a file name, you just put a URL, say to like GitHub Mimikatz, then it'll actually go fetch your payload for you. And this is really any Windows application that has a file open GUI. And so you can automate that with the send keys class and actually have it open up Notepad, send Control-O to open, Control-A, or enter, type the keys to your URL, hit enter, wait a few seconds, Control-A to select all, Control-C to copy, and then back in PowerShell, rip it out of the clipboard and invoke it. And PowerShell never makes a network connection. Notepad does. COM objects. So a more, like, you'd hope that most users would see if Notepad's flying up, even though this code actually pushes it off the screen. The file open prompt will still pop up, so hopefully users would see this is weird, like maybe I should do something about this. So a cleaner way to do this, to push off your remote connections to another binary, would be through something like COM objects, where you can push it off to WinWord, Excel, Internet Explorer. So Notepad making a network connection should be like a pretty big red flag. But what about Internet Explorer making a network connection? That's par for the course. So there's a lot of sneaky ways that you can use other binaries to do your dirty work for you. Inline scripting. So PowerShell supports inline scripts, primarily C#, Visual Basic, and JScript, and a few versions of C#. So what that means is that you can just put in C# code as a string, let's say, and then use this add type. Now, this is actually quite noisy, but I don't know if attackers just don't know that or if they just don't care because they use it a lot. Particularly, attackers will use, they'll basically create a C# shellcode loader and then just compile it on the fly. Now, what this does is it actually, PowerShell, when you run that add type command on your target system, it will then run CSC to compile it, and then that will call CVT res. And there's a lot of artifacts that are left behind, which we'll talk about in the next section. Visual Basic is very similar. It'll launch a VBC instead of CSC, which is a lot less common. Or if you don't want all that stuff happening on your target system, if you want to be a little cleaner, you can just on your attacker system do the exact same thing and just compile that sucker and then take it in a byte stream and then run that byte stream and load it directly using this reflection assembly load method. And then none of that noisy stuff happens on the target system. Now, the interesting thing is that, so if you've played around with PowerShell logging, you do things like creating that net.webclient class and run download string, then that will show up in PowerShell logs. However, if you are doing that from a C# or VB script application, even if it's running inside of PowerShell, that logging never happens in PowerShell logs. So there are some advantages as an attacker to do that. So again, I say this for a defender's perspective, don't count on those always showing up in logs, because if an attacker's hosting it inside of PowerShell in another application, then you're hosed. So how is the obfuscation in CradleCrafter different than Invoke obfuscation? So download string. One way that we can basically, there's ways in Invoke obfuscation that all you need to do is treat that as a string, and that's how we do the concatenation and reordering and stuff like that. Well, there's other ways to get the string download string without ever specifying it. So for example, we can just say new object net.webclient, show me all the objects that are out there, .psobject.methods, or show me all the methods that are out there for this object. You can do something similar with getMember, when both of those are options in the tool, but we'll just stick with the first one for now. And so you'll see it has all the overloaded definitions. Well, what we can do is we can just say, yeah, I just only care about the one where the name is like download string. And then we can just use wildcards, or then we'll grab the name out of that to get that string. So we can also just use wildcards like this. This is a screenshot of some of the code. Any of those wildcards will work. They will only return download string. So this is now going to return the string download string. So we plug that in. And that .invoke is only necessary in PowerShell 2, but I include it in there so it works on whatever PowerShell version you're running this payload on. Next is new object. And so again, we can say get command new object. And get command actually has PowerShell object being returned. But you can invoke it with a dot or ampersand, and it will actually invoke that object, which is the same as running new object. And so we'll randomly choose get command or one of its aliases. We'll just use a command, because PowerShell automatically prepends get dash to anything if it's also a commandlet name. Fun fact. For new object, we'll just randomly select one of these wildcarded fields, and now this is new object. Now, interesting part is, since we obfuscated download string, we also introduced a second new object into our command. So I've handled all of these via tags in the code, so that now whenever you update new object, it'll update all of the new objects in the code, even if one is introduced later. This is also just a random PowerShell 1.0 syntax for also running new object. And it's pretty crazy. You can see this bottom part, this G. This is actually get command name, and then this N asterisk CT is a new object. Now, there are a lot of pieces that I just randomly choose behind the scenes, and there's not as much access to change, like where object, where, question mark, stuff like that. But again, as defenders, if you're only looking for -like, there's also C-like and I-like for case insensitive and case insensitive. So as you're writing triggers as a defender, make sure you're taking into account all these options. $_ this is just the current variable. But as you can see, there are a lot of ways you can get a variable value. $_ is a great indicator in a lot of cases, but there's totally ways around it. And these are all options in the tool. Invoke expression leads us to our third section, all the obscure invocation syntaxes. So IEX, everyone uses that, won't talk about it. You can get IEX through get alias or get command, like you see here. PowerShell 1.0, we also have get commandlets to basically also get invoke expression, or we can just use the invoke script method, which will handle both expressions or script blocks. Invoke command, which requires script blocks, not an expression, but we can convert expressions to script blocks, which is all handled in the project. You can also just create a PS run space, add your code, then invoke it. Concatenated IX. This is definitely the craziest one, so let me come back to it in just 1 second. The last three, invoke is workflow. This was introduced in PowerShell 3. I've actually never seen this one used in the wild, but I'm hoping one day I will, because it's kind of fascinating. The last two are only for web-based, or not web-based, disk-based Cradles, just dot sourcing your script, or import module, which will just run that code. Concatenated IEX. So again, this is what this is as far as I took this in Invoke obfuscation before this project. But another thing that we can do is, instead of always saying $inv comspec, we can do something like this and start to use these asterisks to basically retrieve those variable values. Now, the last thing, let's say that we take a string. In this case, it's an empty string. It's just 2 ticks. And let's pipe it to get member and say, what are all the members of a string? One of these is called index of. And conveniently, that name has the letters I, E, and X in it. This is looking interesting. So what if I just say, okay, string.index of, what are all your definitions? There's lots of E's, lots of I's, lots of X's. So what I can do is I can just cast that to a string. Now, it's one long string. Then I can just say, okay, the 0th, the 7th, and the 8th index is the letters I, E, and the X. Let me grab those, join them back together, and I get the string IEX. And so then all I have to do is invoke it, and that's invoke expression. And so this is a screenshot of the code of a lot of different methods, index of any, all that stuff, and then all the random options that works across all versions of PowerShell to produce the strings I's and E's and X. And again, I don't do this to be cruel to defenders, but I don't want people, including myself, writing signatures just looking for 0, 7, 8, because there's tons of different options that you can use. So how do we detect this stuff? Well, for starters, we need to think more than just PowerShell, right? Just look for network connections in general, and a lot of these Cradles are casting off network connections for other binaries to do, like bits admin, which uses SVC host, WinWord, etc. For send keys and Notepad, Notepad and SVC host make a lot of network connections depending on the size of the payload. Parent-child relationships, this is still really valuable, but there's totally tons of ways to get around this, just from the simplest one being, if an attacker renames PowerShell.exe to foo.exe and then runs whatever they want, will your detections capture that? They'll all hit the PowerShell logs, depending on the versions of PowerShell and if you have that stuff enabled, but a lot of people are just looking for Excel spawning process name PowerShell.exe, and that's going to burn you, and attackers are totally renaming stuff before they run it. Event logs, besides everything in PowerShell and your command line stuff, for example, bits has a default, it's actually enabled by default, event logs here you can look for. DLLs being loaded. When something's loading Internet Explorer with the COM object, it actually loads IE proxy.dll, which is somewhat usual depending on your environment. PowerShell loading RasMan and RasAPI32.dll. These have been really, really helpful in some investigations, especially over the past year, because what's interesting is that when PowerShell loads these, which is the Remote Access Connection Manager, you'll also see that in prefetch files. But the coolest part is that whenever a binary loads these DLLs to make a successful network connection, it will create these registry keys, these tracing registry keys, which are just there so you can basically update information. Say, I want to do full-blown tracing on this sucker. But what's great is it also shows the first time that binary name made that network connection. So in environments where PowerShell is not being used much to download stuff using these DLLs, when certain financial threat actors go in, and that's basically exactly what they use, we just start looking for systems that have these reg keys created by a binary called PowerShell. Now, you could totally rename PowerShell and get around this, but a lot of attackers are lazy, so this is actually a really cool indicator that we've used in a lot of engagements. Remember I was talking about when PowerShell loads C#, it's really noisy. It spawns CSC and CVT res. Those are all going to show up in app-compat, or one after the other. So in the same investigations, we'll see these attackers happen to use PowerShell, but the first thing they do is compile C# code for their shellcode loader. So we'll look for systems where they have app-compat values of PowerShell, CSC, and CVT res. And cached temporary internet files. A lot of these memory cradles actually do have content hit disk, typically in temporary internet files. So it's something to be mindful of as defenders. It's a good place to look, especially if you're easily able to run YAR rules or stuff like that. Because a lot of attackers aren't going and cleaning up what hits disk. So I have 7 minutes left for a demo. My only disclaimer is that you please do not use this tool for evil. This is for educational purposes, and if you have consent, explicit written consent from a client to destroy their environment, then hopefully this will help you in your red team. And hopefully the information in here will help you be able to provide back to the client to say, hey, here's some stuff you could be looking for. So this is, again, all you have to do is just run import module, and then we'll run Invoke-CradleCrafter. I like ASCII art. So this is just a little fun sample of actually obfuscating one of the Cradles. Is this too big? Is the text too big? It's a little large. Is that better? All right, perfect. Beyond all the ASCII art stuff, I really like colors in my projects, and so I try to make it as user-friendly as possible. So anything in yellow will take you to a new menu. So our menu option is down at the bottom of memory and disk, but you can see if you just type help at any point, you'll come back here. So for example, we have a tutorial. So if we just go to that, it'll kind of give you a walkthrough. So basically, for Invoke-CradleCrafter, all you do is supply the URL of your payload that you want the actual result to go download from. You can also set it to a path. or you can also do a post-cradle command. And that becomes important for certain invocation options, where let's say if you want to remotely download invoke Mimikatz and then run invoke Mimikatz dump creds, et cetera, then you might have to actually have that put in the same piece if you're using some of the workflow invocation options. So that's something you can configure as well. But let's just set a URL. And I have a little something in localhost. So we'll set that. And so if we go into disk, we'll see these are our disk cradles here. But memory is more fun, so we'll just go back and go there. So these are all the cradles, all the memory-based cradles that are available. And as you can see, the ones that are PowerShell 3.0 very explicitly say so. So PS web string, this is the net.web client download string. Again, the most common thing we see attackers using. So let's just go into that one. And as you can see, whenever you enter a new Cradle, it gives you information about it. Compatibility, dependencies, footprints, but again, indicators. Hey, this happens to load Razman DLL and Raz API 32 DLL. Artifacts, where could I find this? How about the PowerShell prefetch file? Or these registry keys, these tracing reg keys. So again, for each Cradle, and some of them have a lot more artifacts, I want to make it as easy as possible to understand what's happening behind the scenes, where evidence may be left behind, and how we can, as defenders, become better. And as red teamers, become more particular in which Cradles you use in which situations. So here are our options here. Rearrange is the first one. And so what we can do is, right now it's just a single one-liner. Or we can actually break that up into practically named variables, like WC for web client URL. Or we can do random variables with random set variable, get variable syntax, like you see here. Now, anything that, you'll notice the command, anything that you've entered, it shows up in blue. And then the things that just changed in the last obfuscation round are set in yellow. So you can very easily see what just changed. And so you can just keep running this until you get something that you really like and say, OK, that looks good. We can go back. Commandlet is the next one. So again, by default, it's just the plain old new object. But what we can do is we can do the get command. Actually, this is running off the screen. Yeah. Or we can do the PowerShell 1.0 syntax. So we'll just go with that one. Method for download string. Instead of just download string, we could enumerate all the objects. And then this is now download string. And then for invoke, you can see we have 10 options here, or really 9. One is no invoke. And this is really if you want to basically obfuscate everything and then just run it locally just to download the contents to make sure it's actually working. You don't necessarily want to run beacon on your system as you're testing your payload. But we have the regular IEX. We can use get alias. Again, this is off the screen. So that's a get alias right there. 9 is concatenated IEX, which is, I think, the most fun. So again, the environment variables, this is public. So using the environment variable called public and grabbing the 13th and the 5th and then adding an X after that. So after you've done all this, what you can do is just run test or exec. And it works. So now you've gone through all these options, and maybe you want to say, hey, I really like this set of combinations I did. At any point, you can just go to show or show options, and it'll give you all the information. Again, yellow is the stuff you've actually inputted, and then you have, here's all the execution options, or the obfuscation options that you ran. Here's your final result. Here's the length, which is important depending on where you want to put it. And you also have this command line syntax, so you can always just run this non-interactively if you want to set it up in some other framework or project. Now, if you don't want to go through all these options, then let's just remove the obfuscation. You could just go to this all one, and it'll just randomly choose the order and choose all that stuff, and you'll get something a bit different every single time. And the very last thing I'll show you, my last minute here, is some of these get really crazy. Like PSCOM IE using Internet Explorer. Again, a lot more information here of what's happening behind the scenes. And this is the default Cradle is already that large. You can see all the different options that you can go into. And so again, if I just go to all, it'll run through all of those. And now this is a Cradle that will use silently Internet Explorer to download the content and run it. The last ones that I added are actually C#, so you can do inline C# or PS compiled C#. And this is all regex accessible, so you can just do full-blown regexes to navigate the menus and stuff like that. And this one's really cool because what it's actually going to do is it's going to generate the inline C# and then compile it on your system. Oh, wait, did I go in the wrong one? I did. PS compiled. There we go. So now it's running CSC on your local system, compiling it. It's actually reducing a lot of the adjacent zeros with something like this. So basically, hey, instead of printing out 360 zeros, let me just do this on the fly. And now there's your payload. And again, this is going to access system.net.web client, and it can even invoke commands inside of there, but that'll never show up in PowerShell logs, the loading of that DLL, because it's all done in the context of C#. So as a defender, you definitely want to be looking for this, but there's tons of ways you can obfuscate even that. So it's not all doom and gloom. Do not run away from PowerShell. PowerShell is incredibly useful, and it is not going away anytime soon. Upgrade to PowerShell 5 as soon as possible. Enable those logs. Expand your detection to include additional artifacts, not just what you see on the command line. As defenders, we need to be breaking our assumptions of what we think and know to be possible, because there's always more that you can do, and we need to be aware of that so we can more robustly set up our detections. And hunt not just for known bad syntax of things that attackers are actually using, but also looking for indicators of obfuscation. Again, how many tick marks are common in a command line for PowerShell, or how many asterisks, things like that. And we'll talk more about that on Friday with Revoke Obfuscation. Except that you're going to miss stuff. No one's perfect. We all fail every day, and hopefully we're seeing those failures and learning from them. But the most important thing is to learn from our mistakes and then share with the community, just like this. Because we all learn and are all on the shoulders of other people. So I think it's really important to do that, especially our failures, because we all can learn from successes and failures. Lastly, I'd just like to say thank you to a lot of the awesome colleagues I get to work with on a day-to-day basis. And then especially my wife, Paige, because she watches me write a lot of code, and that's like not the most fun thing for her to do. And so she's been really supportive through all this research and development, and so definitely very appreciative to her. So thank you very much.
Thank you very much. That was really funny and a bit scary. And I have just one question, because when I was a kid and used to do pen testing, everyone was popping a interpreter shell. But nowadays it seems like we don't need a interpreter shell anymore, because we can do everything they used to do with Meterpa more or less with PowerShell. And is that how you see attacks that you've been investigating as well, that people are more using this?
Yeah, absolutely. I mean, and the other interesting thing is that there's so many attack frameworks that are coming out with PowerShell that a lot of APT groups are actually using off-the-shelf frameworks like Cobalt Strike or Empire, often to blend in to look like pen testers. And so never discount what's publicly available, because attackers are using that as well. But yeah, definitely see an uptick in PowerShell. If all defenders upgraded PowerShell to version 5 and enabled logging, I think we'd actually see attackers move away from it, because it's insanely robust. But most people don't enable logging in the first place, so I think we have a long road to go before it becomes obsolete. But yeah, it's pretty ugly out there.
Yeah. Okay, any more questions from the audience? Yes.
Yeah, so doesn't PowerShell implement any kind of instrumentation interface for AV vendors or something? Some things you can put? Some of these key invoke methods that would bypass a lot of this?
Yeah, exactly. So the question was, does PowerShell provide any kind of interface, API interface or hooks so AV can basically integrate with it? And they absolutely do. In PowerShell 5, they've introduced AMSI, which is the anti-malware scan interface. And as an AV vendor, you can register to that to get access to it. And again, it's way more than PowerShell. It's basically like JScript, VBScript, like all these interpreted languages. You can get access into that data. So the thing to keep in mind is that for PowerShell, you'll get access to what are the script block logs, which is EID 4104, which if you look at Invoke Obfuscation, and even this, all that obfuscation is still going to be there. The things that'll unravel is like if you encrypt it or encode it like 10 different times, it'll basically show every single one of those layers, and it'll get you down to the last bit, which is huge. Like, it's insane. It's so cool that it does that. But you still have to keep in mind, are there tick marks, are there concatenations that will throw off regular string searches? But that's where more sciencey techniques come into play, like Revoke Obfuscation, where it'll basically just nail that stuff to the wall.
Yeah, because you should be able to bypass all the string concatenations and catch after it has resolved the string.
Actually, not exactly. I definitely thought that too, and talking with people who are much more intimately familiar with those details than I am. That's all happening after that last script block log. Even if you dump memory, and you'll still see the obfuscated script, which we've done quite a bit with. I'm not a memory expert by any means. If someone knows how to do that, please talk to me, and that would be really, really cool to see.
But are those logs the same thing as the AV instrumentation interface that you...
Yes, AMSI will provide access to exactly what you see in the script block logs, which still has that last bit of token layer obfuscation. But again, that's still huge. Like that's so much more than anything else out there. So it's really cool they do that. But there's only, I think, 3 AV vendors that have implemented it, and it's been out for a year and a half now. To the best of my understanding today, you have to be a registered AV vendor, but I'm very hopeful that there will be more openness to that going forward so that anyone can just implement it for their organization, because that would be really, really cool. The craziest part is that provides you preventative. You can actually say go or no go to the code. It's not just detection.
Do you have a short comment on Bash and Linux binaries on Windows?
My short comment on Bash and Linux on Windows is that I don't know anything about it. So not exactly. I think it's a really cool research area. I don't think we're going to see attackers really using it wide scale until they know it's going to be on every system. That's why PowerShell, since it's so ubiquitous, attackers love it because it's always there. So maybe if there's some kind of like, I don't know, like popular like, if SCCM comes out and says, hey, we want to use Bash and Linux for some reason on Windows, like if some big player in the game starts to use that by default, then I think attackers will start to use it because there's a good enough chance it'll be there. But again, that's not my field of expertise, so I'd definitely love to hear otherwise. Or I hope I never hear about it, because then attackers aren't abusing it. So, yes?
I wonder if you know if somebody has been trying compiler optimization techniques as a way to reverse your obfuscation.
Yeah, so the question was, do I know anyone who is basically working on ways to de-obfuscate my obfuscation? God, I hope so, because it's awful trying to do it manually. I do have some really shoddy scripts that I use to reverse a lot of it, but nothing that I would be willing to put my name on and put out in public. So I'm really hopeful that someone out there is working on this or would like to. Please hit me up. I'll give you a lot of information, anything I can to help, because I definitely don't want to try to write that. But yeah, today people aren't even really detecting it in the first place. So that's why myself and Lee Holmes put together the Revoke Obfuscation project. So at least if you can detect it, then it doesn't take that long to deobfuscate it, but at least this is something bad. I need to be worried about this and look at it. So again, thank you very much. And I'm around all week, so please come ask me any questions or say hello. Thanks again.
Okay.